This practice that we're going to do right now is no calculator. So you are not going to use a calculator for it at all, okay? So let's put those away for a second. I don't you have on I just don't want you using it. And then we're going to finish our notes and we'll use a calculator for all of that. Okay? All right.
Boy, yeah.
Yep. Tomorrow.
Stringers fun.
Stringers, yep. All right, so everybody got to practice, is that correct? Okay, so here we go. Here we go. Number one, we're going to solve this system. Okay? So, 5x squared minus y equals 3, and 3x plus 2y equals 7. Look at these good little fellows. They don't have math today, so they're completely depressed and sad. Yeah. All right, what's your thought on this? We're going to solve this system. What's your idea? Now, elimination, I could eliminate the y's, but be careful because these aren't going to combine, they are separate. So it's okay. She says, what if I multiply the top equation by 2? Kids, this is perfectly okay. It's going to give you 10x squared minus 2y equal to 6. Now, when you add that to your other equation, the y's will be eliminated, but don't accidentally combine these. This is 10x squared plus 3x equals 13. You see that?
Yeah.
Yeah, they don't add. Okay. So now what? Subtract the 13. So we have 10x squared plus 3x minus 13 equals 0. Well, yeah. Now, hopefully this thing factors. But if it doesn't, I can always use my quadratic formula, right? Some of these numbers, it looks like it might factor. 10 and 13. Let's see, does that work? Yeah, I think that works, doesn't it?
Yeah.
So what does that mean? That means x is going to be either, set this equal to 0. So x is going to be negative 13 tenths, or x is going to be positive 1.
Yeah.
Now there was something like this on your homework, and some of you screwed this up, so pay attention. Your answer to these systems of equations is going to be an ordered pair, an x and a y. Because we got 2 x's, we're actually going to get 2 ordered pairs. And the x is negative 13 tenths, or the x is 1. Now, where do the y's come from? Plug them back in. And I would definitely plug them back in, I think, to this equation. I think that's going to be easier. It doesn't matter. Plug it in wherever you want. I'm going to plug it in here so I don't have to square anything. So I'll do 1 first because it's the easiest. If I plug 1 in for my x, it says 3 plus 2y equals 7, right?
Yeah.
Which means 2y equals 4, which means y equals 2. And I pair it with the 1. The 2 is the y that goes with the 1, that's the x. Now I have to do negative 13 tenths. Yucky. So 3 times negative 13 tenths plus 2y equals 7. This forward, I use without a calculator? Yes, you can do this without a calculator. So I'm going to multiply these two together and I get negative 39 tenths plus 2y equals 7. Now, if the fractions bother you, you could multiply everything by 10 and get rid of them. So negative 39 plus 20y equals 70. You still with me?
Mm-hmm.
Okay, so now, if the fractions bother you, you could multiply everything by 10 and get rid of them. So negative 39 plus 20y equals 70. 70. You still with me? You still with me? then I add the 39, so 20y equals 109, and y equals 109 over 20. Now, I know that's a hideous answer, but it wasn't bad. The math wasn't bad. You can do that. Just don't panic. Okay, let's take a close look and make sure you followed that, because like I said, some of you missed it in your homework. Kamala was second guessing herself, but I think elimination is probably the easiest way to do this problem. You could substitute, but I think elimination is the easiest, so good job, good choice. Okay, everybody good with that?
Yeah.
All right, now we got a bunch of matrix stuff. So A, B sub 2, 1, what does that mean?
Column 2, row 1.
Other way around.
Row
Roman Catholic, RC, row column. So B means look at matrix B and find the number that is in row 2, column 1. So what number is in row 2, column 1? 2. So the answer to A is 2. Look at matrix B, second row, first column. In other words, the first number in the second row. What are the dimensions of matrix A?
No.
2 by 3. Do not mess that up. It's rows by columns. Rows go this way. So it's 2 by 3. What does C even mean? Transpose. And what does it mean to transpose?
Interchange the rows and columns.
Very good, Abe Palmer. We're going to interchange the rows and columns. So what was row 1 becomes column 1, and row 2 becomes column 2. C minus 2D. Now, two things. First of all, what do I do with 2D?
You got that.
I just multiply everything in D by 2. So I did that right here. Are you with me there?
Yeah.
Just multiply everything by 2. Now, first of all, I guess I should have figured out, can I even do this problem? Yes, because these two matrices are the same size. Now, I know they're square. They don't have to be square. They just have to match. And they do. So this is a doable problem. So now I'm going to get my answer. 1 minus negative 2. Negative 1 minus 10. Negative 2 minus 8. And 3 minus 6. How does that look to everybody?
It's good to me.
Before I write down the next question, can I do it? Can I do A times B? Ooh, what are the dimensions of A?
3, 2 by 3.
Yeah, it's a 2 by 3. What are the dimensions of B?
3 by 3.
To multiply, remember these have to match?
Yeah.
And they do. So here we go. We were hoping we weren't gonna have to do this, but guess what? We do have to do it, so here we go. Okay. All right. Get a new marker for this. Since I have a 2 by 3 and a 3 by 3, I can multiply and my answer will be another 2 by 3, correct?
Yeah.
So that means I'm gonna have 2 rows and 3 columns of numbers. So I have to fill in all these blanks. So remember how this works. To find that number right there, first row, first column, we multiply this set of numbers times this set of numbers. So we multiply 1, -1, 5, times 1, 2, 3. So first times first, second times second, third times third. And then we're gonna add all those up. So what is that? We're gonna do this without a calculator, so let's see. Did you get 14? It's easy to make arithmetic mistakes, so be careful. Now, we'll do exactly the same thing, but we'll take our 1, -1, and 5 times this column. -7? And then we do it again. We take our 1, -1, 5 times this column. $28? Now we do exactly the same thing, but instead of using 1, -1, 5, we use 042. So 042 times the first column, the second column, and the third column. Okay, I did that kind of fast, could be mistakes all over the place.
I think the 2 is supposed to be negative.
2 is supposed to be negative. This 2?
No, in A, the matrix.
Oh, wait, over here?
Yeah.
Oh, shoot. I didn't copy it right? Oh, I didn't. Okay, so that changes a few things. A lot of things. So, 2, did that look better?
Yeah.
And 6? Thank you. Is that okay with everybody? All good. All right, determinant of A. What is the determinant of matrix A?
I don't think there is one.
There isn't one. Very good. Why?
Square.
Because it's not square. Kids, if you're not square, you do not have a determinant. You do not have an inverse. You do not have a trace. None of those things. You got to be square to have all those things. Okay, so no solution. Can't do. How about B? I think we can find a determinant for B. So what's our strategy for that?
Take the first 2.
Copy and paste your first 2 columns. Do negatives matter?
No.
Yeah, they do. Don't leave negatives off. Remember, I left one off and missed the problem because of that. So make sure you're copying all the negatives just like you're supposed to. All right, start right here. This is the starting spot. Start with the first number. Multiply. 5. Multiply. 0. Multiply. -6. I got those to add up to -1. And then we turn right around and do the same thing. Multiply. 9. 0. -10. I got another -1. Now what do I do with those 2 numbers? Subtract. So -1 minus -1, what does that equal?
0.
Ah, that's interesting. We got a 0. The 0 determinant has meaning. For us, we just compare, we got a 0. Our answer is 0. Determinant of C. Can we do that one?
Yeah.
Yeah, and in fact, that one you can maybe do in your head, Because remember, you don't have to do it in your head, but you might be able to, because all you do is multiply the 1 and the 3, right? We get 3, and then we multiply the -2 and the -1 and get 2. And then what do we do with those two numbers? Subtract them, so that determinant is 1. So you multiply, subtract. And now we've got the inverse. So how do we find the inverse? This means the inverse. What do we need to do to make that? First, we find the determinant. So we do just what we did a minute ago. So this determinant is going to be -3, 20, subtracted, I got -23. All right, gonna hang on to that number for a second. I'm gonna use it in a second, but first I have to make a new matrix. By taking these two and flipping them, and taking these two and making them negative. Right? I know it seems very random, and it is, but that's how you do it, okay? And then we take this new matrix that we just found and we divide everything by -23. And then in the answer blank, we put the reduced or simplified version. So -3/23, 5/23, 4/23, and 1/23. There's your inverse. Okay? Now, it says over for Kramer's rule, but there's no problem back there, because you're gonna make it up. You're gonna make it up, so I want you to understand that it doesn't need to be rigged. It doesn't need to be rigged. So, Jackson, give me an equation, X and Y equation.
X plus Y equals 2.
Okay, that is so simple, but okay, we'll go with it. Somebody give me one now that's not quite that simple. Emma.
3x plus 5x, or 5y
Equals
equals 6.
All right, there we go.
So simple.
So totally random, and we're gonna use Kramer's rule now to solve it. Okay, you could substitute, you could eliminate, we're gonna do Kramer's rule. So what's step 1?
Create your box.
Your determinant of the coefficients. So 1, 1, 3, 5. These are the x's, these are the y's. And evaluate it, just like we've been doing. So what's this gonna equal? 5
Yeah.
minus 3? 2. This is no different than the first problem we did. The answer is going to be an ordered pair. And the denominator for both of the or for x and y is going to be 2. Is this coming back to you?
Yep.
So now we're going to do the numerators. So we're going to have a numerator for x and a numerator for y. Okay, who remembers how that works? Nyla?
Put the answers in.
So take these guys right here, cut them out, and paste them on whichever letter you're looking for. So if we're doing x, we're gonna put the 2 and the 6 right here. And then of course we still have the 1 and the 5. And if we're doing y, we're gonna take the 2 and the 6 and put them here. We're not rearranging anything. The 2 and the 6 replace whatever variable you're solving for. All right, then we evaluate these. So 10 minus 6, I got 4 for that one, did you? And 6 minus 6, I got 0 for that one.
2, 0.
So just like before, our final answer is gonna be whatever we get when we simplify, so it's 2 comma 0. Now normally when we make up random problems, we get hideous answers, you guys, that, so perfect. Okay, so tomorrow we have a quiz, it's gonna have stuff like this on it. Everybody got it? All right, put that away. That task is finished. We're now back in our notes, and we are ready for problem 4. Okay, now, leave those handy dandy calculators, because I'll tell you, I grew up doing these by hand, and they're a lot harder by hand than they are with the calculator. Here we go. Actually, let's make sure we all have a calculator today. Last time we weren't too good at this calculator. Do we all have a functioning calculator? You need a graphing calculator. True. All right, you got the right one. I'll get one for you. Well, you can, but you're supposed to have a graphing calculator, so I'm gonna get you a graphing calculator. That's a course requirement for this class. It has been all year, you know it, you know it, you know it. I'm glad you can do that. That's gonna be your calculator of choice. But not in this class, it's not, okay? All right, so here we go. Gauss-Jordan reduction. Here is what I want you to start doing. Whenever it says Gauss-Jordan reduction, we're gonna transform, our calculator's gonna transform a matrix into another form of the same matrix. So we gotta start with our original matrix. Here's what the original matrix is gonna look like. 1, this is problem A. 1, 1, -1, 2. What am I doing?
You're just writing it out.
I'm just writing down the numbers, right? So then the next row will be 2, -1, 3, and 14. And 3, 1, 1, 14. Everybody clear on where that matrix came from? Now, I need you to understand, because we're gonna transform it, but when we transform it and get a different matrix, that new matrix is gonna mean the same thing that this one means. In other words, this column is gonna be the X's, this column is gonna be the Y's, this is the Z's, and this is the equals numbers. So when you see, this is called an augmented matrix, when you see a matrix like this, you need to understand this means 3x plus 1y plus 1z equals 14, okay? All right, so here's what we're gonna do. We're gonna put that matrix into our calculator. So remember how we do that. We go to the second matrix, and since we're gonna put it in, we have to go across to edit. Remember, that's where we put stuff in. So second matrix, edit. Now, how big is this matrix that I'm putting in? What are the dimensions of it? What? 3 by 4. Guys, you gotta get that right. That's a 3 by 4. It has 3 rows, 4 columns. Okay? Now, let's put the numbers in. So. Once you get that last 14 in and you press enter, who remembers what we do? Second click, because we're done putting stuff in. All right? Now, I want you to go back into your matrix mode. This time go over to math. Oh gosh, see that very first thing in that math row? That says determinant. So your calculator will do determinants too. But we're not doing that. I want you to go all the way down the list. It's a very long list. I want you to go all the way down until you find RREF. So you gotta keep going, everybody find it? RREF. There's an REF and there's an RREF. I want you to go all the way down to RR. Okay? Press enter. And then go back into second matrix and hit enter. So now your calculator should say RREFA. Press enter again, and it gives you a new matrix that looks like this. Everybody get that? You got a number off if you didn't. You entered the wrong number. So go back and edit and check your matrix. Now, that matrix means the same thing as it did in the beginning. So I want you to look at this row now. What does that row say to me?
X is equal to 4.
X is equal to 4. So it tells me straight up that my X coordinate is 4. What does it say about my Y coordinate? 0. And my Z coordinate? There's the answer to the question. That's all there is to it. Okay? Now, to help you appreciate your old teacher a little bit, when I was taking this class, there were these. So we had to do operations, what are called the elementary row operations, and we had to physically, through a series of steps, turn this matrix into that. That matrix is in reduced row echelon form. When you do Gauss-Jordan reduction, that is the process that transforms the matrix into RREF, reduced row echelon form. Okay, let's try the next one. Now, the next one, we're going to do exactly the same thing, except, what do you notice about this system of equations? Okay, so in other words, it's got more equations and more variables. Okay, now, we'll just keep them in the same order I have them, and that's fine. But what that means is it's X, Y, Z, W equals. Now, you can certainly turn them around and do them all in a different order if you wish. I'll just leave them in the order they are. So what's that top row going to be? I have 1x, 1y, negative 1z, 0 w's equal to 4. Every variable has to be accounted for. Ooh, what about the next row?
0, 1, 0, 1.
0, 1, 0, 1, negative 4. Would everybody agree with that?
Yeah.
Be organized. It's easy. Next. 1, negative 1, 0, 0, 1. 1, 0, 1, 1. How's that look? Did I get everything in the right spots? So now you're going to put that matrix into your calculator. You're going to RREF it. And you're going to come out with a new matrix that's going to give you your answer within Y. How big's this one?
4 by 5.
Yep, second matrix, edit, 4 by 5. Okay, then second quit, once you get them all in. And then back into second matrix, over to math, and then down the list till you get to RREF. And then second matrix, enter. Now I got some decimals, did you?
Yeah.
They're not bad.
Is it always gonna be like in order? Is it always gonna be like how the X's and like, it's like.
These are that, cause X is that, Y is this, Z is this, and W is
Yeah,
this.
so no.
No, it's gonna be exactly the order that you put it in as. So, my answer is 4.5, 3.5, 4, and -7.5. And when your variables aren't in alphabetical order, you have to label them. Since I chose to leave them in the order they were in the problem, that's perfectly okay. But I have to label my answer then, because the assumption is always, these are gonna be in alphabetical order. If they're not, you have to indicate that. I could have turned my equations around from the beginning. All right, do you feel qualified and confident in trying C by yourself? All right, so go ahead and try C by yourself. Consult your partner as necessary. Oh, crap or what?
Yeah, that's what it said, yeah, I don't know.
Yeah. Okay, well, our little perfect world just ended. Because ideally what happens is you end up, I'm making this up, but you end up with something like this, right? And that literally says X is 1, Y is 2, Z is 3. Okay, well that didn't happen because this part got all messed up. And I have a -4 and a 23 and a 3 and a -13 and all zeros. Does that look like yours?
Yeah.
All right, so let's talk about this. Now, I made a big deal about the fact that this matrix meant X plus Y minus Z equals a number. That has not changed over here. I want you to look at that bottom row and tell me what it says. Be careful. It says no X's, no Y's, no Z's, add up to 0. Wait a second. Couldn't those variables be anything? Well, the bottom row is supposed to address just Z. In a normal problem, the bottom row gives me Z. So this bottom row says 0Z equals 0, which means Z can be anything. So we write that like this. We say Z can be Z. So Z could be 5, Z could be 1/2, Z could be root 17, Z can be anything. Instead of Z being a number, Z is any number. Now, what does this row say? Go up a row, we go back up this way. What does this row say? Y plus 3Z equals -13. But since I don't know what Z is, The best I can do is subtract this over and say y equals negative 13 minus 3z. So if we picked a number, like, said, okay, z can be anything, let's let z be 1, then could we find a y?
Yeah.
Yeah, and it would be negative 16. Okay, but if we pick z equals 2, then we would get a different y. Are you with me? Okay. Now, what's the top row say? X
Plus, or
minus 4z equals 23, which means x equals 23 plus 4z. And that's the best we can do. Unless we have a value for z, that's the best we can do. So how do we write this answer? How do we write our final answer? Well, it's pretty easy. Notice that each answer has a number and a z part. A number and a z part. Even this one, its number is 0 and its z part is 1z. So when we write our answer, we write it like this. XYZ equals a number part and a z part. So for x, the number part is 23 and the z part is 4.
4 and negative 4.
4.
4, okay.
Yeah. I solve for x. So x is 23 plus 4z. All right, and then y. The number part is negative 13, and the z part is negative 3. And then for z, and don't let this one confuse you. It doesn't have a number, so its number is 0. It has 1z, so that one is going to be 0, 1. Everybody okay with that? So, this is a situation where instead of all of these curves coming together at a single point, they're actually coming together in a line. This is the vector form of a line. So here's what's happening in this problem. I need your help. Would you hold this pile up like this? These equations, I've erased my original equations, but the original equations in this problem, x, y, z equations, are equations of planes. So like this is an x, y, z equation, this is an x, y, z equation. She's holding one. So there's 3, hers and my 2 are the equations. They are intersecting like this. Hold yours up a little higher, Kenny. So what's happening is they're all coming together, but they're coming together in a line. Like the binder of a book, all the pages are coming together in a whole line instead of a single point. What happened in our other problem was we had the ceiling and the wall and the other wall, and they were all coming together in that point up there in the corner. So when you get an answer like 1, 2, 3, that's a point. Whatever you're doing is meeting in a point. When you get a wacky thing like this, it means they're intersecting, in this case, in a line, in some other thing, not a point. Okay? All right, well, there's one more. Thank you. Thank you. There's one more. It's a biggie. I'm sorry, that was kind of wacky, but that's happened, so we have to be ready for it. Let's have you try that last one and see about that. totally done on the calculator. So the work you need to show is just what I'm writing down. You have to write down your in matrix, RREF, and then your out matrix. And then write your answer and you're all done. There really isn't anything else for you to do. Please tell me this one's not wacky. Oh, cradola! I'll have you make one up here in a minute so we get another one in that's not wacky. Did you get a bunch of decimals?
Yeah.
All right, let's fix that. Just to make sure I copied right, do you have like a negative 3.45?
Yeah.
Okay. All right, so here's what I want you to do. Just press your math button, your actual math button, and then hit enter a couple times. And it's gonna give you the matrix with fractions in it. Does mine look like yours? Perfect. Okay. All right. These were what letters? A, B, C, D?
Yeah.
Okay, so start at the bottom. What does that bottom tell you since it's all zeros?
Equal to D.
D equals D. D equals D. D can be anything. But what does the second row from the bottom say? C plus 3/11 D equals negative 7/11. Kids, that's what this says, right? Remember, this is the equals. So C equals negative 7/11 minus 3/11 D. Now to Jake's point, make sure you're subtracting that over. You gotta get C by itself. What's our second row say? B plus 5D equals 5. So B equals 5 minus 5D. And top row, A minus 38/11 D equals negative 3/11. Beautiful, so negative 3/11 plus 38/11 D is my A. All right, are we all hanging in there?
Yeah.
So here we go, it's time to write our answer. So this time we have 4 variables, so here they are, A, B, C, D. And each variable has a number and a D component. So A, for example, is negative 3/11 plus 38/11 D. B is 5 minus 5D. So my numbers are going here and my D coefficients are going here. All right, let's see. Negative 7/11 and negative 3/11 too. And then don't let this confuse you. What is the number part for this? 0.
0, 1.
And what's the coefficient part? 1. So it's 0, 1. This is called the general solution. This describes all of the answers. If you let D be 6, you'll get one set of answers. If you let D be 7, you get another set, and so on. Okay? Now, I wanna try, I gotta make 2 points here, we make 2 points, so we're gonna make one up. So I need an XYZ equation from Van. Van, give me an XYZ equation.
Like the coordinates?
Just like,
Oh, just like, x plus 2y minus 3z equals 17.
all right? Eli, give me another one.
3y. Oh, wait, I forgot.
It's okay, let's go with it, let's go with it.
Go with it. Minus, 40 equals 15.
15? All right, and I need one more, let's get it from Kara.
2x minus 8z equals 23.
All right, here's our system, let's solve it. Let's solve it. This one is not rigged, so I think we're gonna come out with an answer. It's probably gonna be hideous, but it's not gonna be parametric like this. It's gonna be a real life answer, I hope. So, what's our matrix look like? 1, 2, negative 3, 17. Watch the zeros here. 0, 3, negative 4, 15. 2, 0, negative 8, 23. All right, let's RREF that guy. You're probably gonna need your fraction, your math frac button, since we didn't rig this at all. How did I do? Did I do that okay?
Yeah.
All right, so, 2 things there. First of all, we just randomly made up a system, and we got crazy answers, so we math frac. Our answer came out to be a normal point, so 145, 20 seconds, 37, 11, negative 27, 20 seconds. That's it. Okay? My final point of the day. All right? I want you to do what you just did, so the matrix is already in there. But instead of RREFing it, I want you to REF it. So the second matrix, math, go down to REF, just regular REF. Second matrix, enter. And go ahead and math frac that. And what came out is a matrix that looks like this. This is when we REF'd. We got this. Now, quite honestly, if I have a calculator, I am never gonna REF. But back in the days when I was doing this by hand, it was often easier to make the matrix look like this rather than to take it all the way to this. Now, the beauty of our reduced row echelon form is it literally tells you x equals, y equals, z equals. But getting these zeros takes as long as getting these. So getting the matrix from there to here doubles your time. So, what does this mean? Doesn't that bottom row say the same thing that it did over here? Doesn't it say that, see?
Yeah, so you have to like plug in your.
Exactly. So if you just stopped here with REF, then you have to do back substitution. So you have to take this and plug it in here. You see that? And then I would find my Y value. And then I would come up here and do the same thing. Okay? So you can say, yuck, I don't want to do that. But remember, if you had to find these zeros by hand, that would be a lot of work too. Moral of the story, we're not REFing. We're always gonna RREF. This is row echelon form. We're always going with reduced row echelon form. Okie dokie smokies? All right, I need to take attendance real quick since I haven't done that yet.